Have you ever wondered why some pain just sticks around? Well, you're definitely not alone. Today, we're diving into a really incredible breakthrough in how we understand chronic pain. We're going to talk about a hidden switch deep inside the brain, one that doesn't control the ouch factor, but the suffering, that emotional weight that can make pain so unbearable.
You know how it goes. You twist your knee, it hurts for a while, and then it gets better. But what about when it doesn't? Why is it that some pain just overstays its welcome, turning from a temporary warning sign into this permanent, miserable house guest?
And make no mistake, this is a huge deal. Chronic pain isn't just a personal struggle, it's a massive public health crisis. We're talking about something that affects more people than heart disease, cancer, and diabetes combined. It's a leading reason for long-term disability, so finding a better way to treat it is one of the biggest challenges in medicine today.
So, to really appreciate just how big this new discovery is, we first have to understand the puzzle that has kept scientists guessing for decades. Let's take a look at the clues.
Okay, so think about pain in two basic ways. First, you've got acute pain. That's the useful kind, believe it or not. It's your body's alarm system screaming, "Hey, that stove is hot, move your hand." It protects you. But chronic pain, that's like the alarm system has gone haywire. The danger is long gone, but that siren is just stuck on, blaring and blaring day in and day out.
So, where exactly is this faulty wiring? For years, the search focused on the original injury site, or maybe the spinal cord. But it turns out the real culprit was hiding in a totally unexpected place: the brain itself.
And the trail led them deep inside the brain, but not to the parts that just process physical sensations. Nope, it led them to the regions that control our emotions. And that right there was a critical clue. What if chronic pain isn't just a physical problem? What if it's an emotional one, too?
They eventually zeroed in on one very specific area: the central amygdala. Now, you can think of this little cluster of neurons as the brain's emotional command center. And researchers started to get this hunch that this area wasn't just handling fear and anxiety. They started to think it was also the place that was dialing up the suffering of chronic pain. You know, as the lead researcher, Dr. Gregory Scherer, put it, this was a pretty unconventional idea. I mean, everybody knew the amygdala as the fear center, but his team saw that it also lit up during pain, and that led them to ask a game-changing question. What if the amygdala is the exact spot where the simple sensation of pain gets twisted into the emotional burden of suffering? And that one question, well, it led to an absolutely groundbreaking discovery. Their investigation finally unmasked the precise neural circuit responsible for all the misery of chronic pain. So here it is, the big reveal. The team at Stanford figured out how to identify a very, very specific group of neurons inside that central amygdala. And it turns out these cells act like a master switch. But get this, it's not a switch for the pain itself. It's a switch for the negative emotions, for the unpleasantness that's attached to the pain.
They've given it a name, the affective pain circuit. And this is the real key. For the first time ever, science can actually separate the ouch of pain from the emotional suffering that comes with it. This circuit is kind of like a volume knob, but it only turns down the suffering part.
So how on earth did they prove this? It was through this really elegant experiment with mice. Using some amazing technology, they could target these exact neurons. Then, just by using a flash of light, they could switch them on. And bam, the mice instantly became hypersensitive, avoiding things that wouldn't normally bother them. But the real moment of truth was what happened when they switched those same neurons off. And the results were just, wow, they were stunning. Flipping that switch to off didn't stop the mice from feeling pain, but it completely changed how they reacted to it. Their pain-related behaviors just plummeted. This was the smoking gun. They had found the switch that separates the sensation of pain from the suffering it causes. Okay, this is really the most important takeaway here. They didn't just make the mice numb. The mice could still feel a potentially harmful thing. That helpful alarm was still working, but they weren't emotionally distressed by it anymore. They effectively silenced the suffering without silencing the actual sensation. All right, so this is all incredibly cool science, but what does it actually mean for us, for the future of medicine? Well, it opens up a completely new way to think about treatment. For decades, our main weapons against severe pain have been opioids. And let's be honest, they're like a sledgehammer. They just kind of blast the entire nervous system, which leads to addiction and all these dangerous side effects. This discovery, though, this gives drug developers a super specific laser-like target. Instead of silencing everything, you could design a drug that only targets these specific cells in the amygdala. Just imagine a pain medication that could do that. A drug that dials down the suffering but leaves the helpful, protective warning signal of pain totally intact. This could lead to a powerful, non-addictive alternative to opioids with way, way fewer side effects. That right there is the incredible promise of this research. So, where does this all leave us? What does the future of pain relief look like now?
By pinpointing the exact brain circuit where physical sensation becomes emotional suffering, these scientists have basically given us a map. And that map leads to one profound question. Could we, in the pretty near future, develop a treatment that just flips a single switch in the brain, turning off the misery of chronic pain right at its source? Well, based on this research, the answer might finally be yes.